Hey everybody, this is Larry. This is me over in Q4 of the bi-weekly contest 160 minimum stability factor of array. Hit the like button, subscribe button, join me on Discord. Let me know what you think about this one. So this problem I actually dig a lot, but if you look at the time, I spent a little bit about like 40 minutes or so, maybe more, 48 minutes, almost 50 minutes. But if you watch the live portion, honestly, I made a mistake in the sense that I ran out of hard drive space recording it. So then my computer just crashed and I took like 10 minutes. And it was right before I hit the first submit. So if I had like another, I don't know how much long I took. I think I ended up taking about 10 minutes trying to bring it back up and then deleting files so that I could record. So that took a bit of time, not gonna lie. So it's not definitive of why like if you sometimes look at someone's time for difficulty, that's not all of it. That's all I'm saying, right? Like it's easier than that. That said, I think it was very tricky and a lot of the wrong answers. I think one wrong answer was legit in that I didn't consider ones because there's a case where you could return zeros as an output, which I didn't really consider or think about too much. If they're all ones, for example. And then the other cases are just because Leetcode sucks with Python. The way that I wrote my Python is just slow enough, and I kind of wrote a couple of optimizations and it didn't work. I did have an optimization that worked at the very end, but I submitted in Java, it worked, and then I continued to optimize my Python code to get it to work, but it was just a lot more wrong answers as a result, which I honestly blame Leetcode a little bit, because if the same code works in Java, why doesn't it work in Python? Any case, okay, so that's a little bit of context about this problem and how I did, sort of a retro. The first thing I want to realize about this problem is that highest common factor is such a weird term, and I think the reason why they use this weird term is that so that they kind of try to fool you up a little bit of using GCD. And for me anyway, honestly, it worked a little bit because I was like, this sounds familiar, but I'm just so confused about reading it. And then the other tricky thing about this problem is that you have to, oops, no spoilers. Is that there can be overlaps in the problem, right? Because I think one thing that I was thinking about is that, okay, well, if you have just some like distinct, or sorry, not distinct, but disjoint longest, subarrays or something like that, then you can think about how to divide them and so forth. But this is not disjoint. For example, you could have, the first 5 elements divisible by 2, the next 5 divisible by 3, and then in an overlapping kind of way, more elements that are divisible by 5 as well, right? So for example, given these cases, your input will be 2, 2, 6, 6, 30, 30, 15, 15, 5, 5, 5, 5. That means that there's a segment of length 5, there's a segment of length 5, and then of length 6, right? So they overlap is my point. So you can't really, you can't just use a sliding window or something like that, or not easily anyway. Maybe you can, but not in a naive kind of way, because you have to keep track of all these overlaps. So those are the things that were the first to come to my mind, right? In terms of trying to figure out how to understand this problem. Honestly, I did come to binary search very quickly, even despite because whether this is disjoint or not, you can do a binary search in concept, right? Because you still have to figure out how to implement it correctly, but binary search is the way. And it's the idea that, okay, for every here, you can always convert a number, and that's what using this max C thing is, the conversion modified. You convert this number to a really, really big prime, or I guess either really big prime or just to the number 1. I think either way it doesn't matter, because that means that you end the streak, right? If you end the streak, let's say you do a binary search, you try, and then this is how you tie into binary search, is that then now you could binary search for the answer. I'm not going over that in detail, what searching for the answer mean. The reason because that this is a hard problem. There are a lot of I think cocoa monkeys or something is the one, or bananas is it? I don't know. I think that's the one that everyone talks about with binary search for the answer, and you could kind of look into that. But the idea here is that the binary search for the answer now allows us to go from left to right in a greedy kind of way. And what I mean by that is that you say, okay, well, let's say we want to search target is equal to 3. And then from here, we go left to right, right? And then now we go 4. Oh, at 4, this contains a streak of 4 characters, right? Or 4. That means that we want to convert this to a 1, or maybe a big prime. It doesn't matter, right? And then now this ends the streak, if you will, of the what did he call it? Of stable subarray or whatever. And then now it is just starting from scratch, right? So now you have 1, and then you're able to kind of keep on doing that, 1, 2, 3, and you go, okay, now this is 1 again, right? And you're able to do that. Then now you count the number of times you modify it, and if the number of times you modify it is less than or equal to max C, then, well, this is a possible good answer. And you binary search, and then you try a smaller target and so forth. So that part I got relatively quickly. The one observation I made at this point, after having seen the binary search, is that, okay, so the num sub I can go to 10 to 9. What does 10 to the 9 mean? 10 to the 9 means that it is roughly speaking 2 to the 32, which also roughly speaking is not quite precise. Or technically I guess it's 2 to the 30, sorry, but 2 to the 32 is the number of bits. But that means that there are, roughly speaking, less than strictly 30 primes, right? And it's actually a lot less than that because it has to be, or it should be distinct primes. And the reason is because if two numbers share, like if 2 numbers greatest common denominator is a 4, for example, which is 2 2s, it doesn't matter that how many 2s you have. It just matters that it is greater than 1. And if you have 2 2s, it is the same as having 1 2 because they share a 2. So in that way, you actually want to cut this to distinct primes, and maybe if you do the math, I didn't do the math during the contest, I just wrote that it is less than 30, right? But you can just do the math of like 2 times 3 times 5 times 7 times ... and it's like x smallest prime or something for something less than 30. I didn't bother trying because it's, you know, the math is still the same, roughly speaking, it's the same big O, right? Which is log of n, right? Log of this n, not the input n, right? So then I was like, okay, so that means that if we were able to prime factorize each number, then we can check each distinct prime because there are fewer than 30, right? Yeah. Basically, if we could be able to prime factorize each number, then we can just check for each distinct prime because there are, say, 30 primes. That means that there are at most 30 streaks to be checked, right? That means that, in another way of saying is that we look at this image, right? If we're here, at most, maybe not here because maybe you discarded the 2 a long time ago, but let's say there are more overlaps with 5 and so forth and 2s, right? If you're here, you're at 30, right? We know that if you have 30 is equal to 2 times 3 times 5, right? Is that right? Yep. That means that we only have to check what is the current streak of 2, what is the current streak of 3, what is the current streak of 5, right? And how we extend it, right? So that's what we have when we have 30. How can we extend the streak of 2, 3, and 5? And all the other streaks don't matter because that means that they end automatically, right? And because we only have to ask and answer this question 30 times, because there are only at most 30 primes, fewer than that, then it makes it n. For each n, we only look up 30 numbers, so it's going to be n times 30. But the problem with that is that we have to factorize each number, right? And this is where we have 10 to the 9 as an issue. Because for 10 to the 9, you know, too big for prime civ, right? I'm not going to go over that because this is a Q4, but just look up prime civ. Yeah. And it is also too big for square root of x prime check, right? By itself, it's not too big. It's like 10 to the 4.5 or whatever it is, right? But if you have to do this for each number, and we have 10 to the 5 numbers, this is going to equal to 10 to the 9.5 checks in the worst case, which is too slow, right? So basically, yeah, 10 to the 9 was the trouble that I spent a long time in. 10, maybe 15 minutes, just trying to think about different ideas. Some ideas I had was like segment tree, etc. There are a lot of different ideas I just couldn't figure out, right? That's why I didn't do them, and I'm not gonna go over them because in too much of detail. I just kind of went, okay, what if there's a segment tree? What would that entails? And I just kind of thought about it, but I really wasn't able to think because things do overlap, so you have to do some sort of things like this, right? Okay, so and that's basically where I got stuck for a little bit, and then I was able to kind of YOLO figure it out a little bit. And the idea is kind of tricky to explain because it's something that, to be frank, I might not have a strong idea of. It's a little bit YOLO. It's a little bit, it worked. And you can watch the live portion to see how I kind of come up with it. And we'll go over this in a sec, but then right as I was about to submit it, my computer crashed and kind of added 10 to 15 minutes to it. But I think the idea here is, how do I say this? So the way that I want to think about it is that we basically keep a table of streaks, right? And the way that I think about it is that it's kind of similar to the bitwise AND thing. Like if you do a bitwise AND of the previous numbers, like in a prefix kind of way, there are only at most 32 or 30, depending on the constraints, number of distinct ways of representing it. And the reason is because it is in order, there's a structure and so forth, right? But and I'm not talking about in detail. It's just that if you know what I mean, then maybe this gives you an idea. If you don't, that's fine because we'll go over it. But the idea here is that if you kind of go backwards, so let's say you have a 30 number, right? You have number 30, and you kind of go backwards to what we have previous. Oh, actually, let me just let's go over this streak real quick, right? Or this series real quick. Right. Something like this. I don't know. Maybe this is right. Maybe this is not. But then now we just have to keep track of all the GCDs. Why? Okay, let's say we have 2. Then now we just have a table that contains 2, and we see 1 of it. And let's just say for the purpose of this, we just ignore all 1s because we don't have to, right? And then 2, and then the second 2, our mapping now goes to the 2 2s in a row, right? And then 6 gets interesting, and then now how we wanted to do. What we wanted to do would have been maybe something like, okay, well, for the 2, we have 3, and the streak of 3, we start at 1, right? But actually, what is more important is that we look at the previous streaks, and that's it, right? Because here, we look at the previous streaks, we see a 2, that means that we extend it to a 2. But instead of saying, okay, now we have a 3 left, so maybe I could have done it that way, to be honest. Maybe I could have. I don't know. I don't think that's quite right, though, actually. We could have, but I don't think it's quite right. Maybe it is right, but I cannot prove it. But the way that I have it is that I just set 6 as 1. The streak of everything that contains 6 is 1, and that's it. And let's say we have another 6 for, we have 2 is at 4, 6 is at 2, right? And then now it gets interesting when we have 30. 30, then now we just take a look at all the other ones, right? That means that here at 2, we have a streak of 5. Makes sense, right? But 6, we have a streak of 3. And then 30, we have a streak of 1. And that's it. The key observation is that we don't need the primes itself. We just need a streak of things. Because here, sure, we represent it as 6. But what we also represent is a 2 times 3. And here, this is a representation of 2 times 3 times 5, right? And the thing is that because this is in a prefix kind of way, right? There are at most 30 different things in this map. In the same way that, this is why I talk about the bitwise AND, but because there are only 30 different primes, because every number here inside this map, every key value is a value on a previous number plus another prime, or technically multiplied by another prime, right? Yeah. And we'll go over it in a sec. So, and as a second, 30 is just the same number except for we increment. So let's just extend, right? And then let's just say now we are doing with 15. So it's a little bit interesting. Well, 15 means that this ends the streak, right? And then now, but here, 2 times 3, what does that mean? Well, the GCD of 15 and 6, or 2 times 3, it's only overlapping in 3. So that means that this new map will have 3 with a streak of 5, right? We could get rid of the 2, it's fine. And then now here, the same way, the GCD of 30 and 15 is just, well, 15. So 3 times 5, we extend the streak from 2 to 3, and then now we have a streak of 3. And that's the key idea in a way in that all the map, because now we remove the 2, we remove all the 2 from all the keys. And that's basically the idea. And here maybe, you know, you could do another one, and oops, typo. And then maybe let's say we have to do another 30 again. Then now we go, okay, well, we have 3. We do extend the 3 to 7. We do extend the 3 by 5 to 5. And then now we have a 30 at 1, right? And that's it. And 30, of course, is 2 times 3 times 5. And as we said before, this is always going to be a number that is this number times another number, right? At most. So that means that if you kind of look at it another way, is that given the previous array or previous map, we only extend the number of keys by 1, meaning that we only have 1 more key that we haven't seen before, right? And then you may say, okay, well, wouldn't that be n squared? And the answer is no, because there can only be 30 distinct primes, right? That means that at a certain, because the number here, x, say, has at most 30 distinct primes, that means that if there are 30 numbers in the map, it represents 30 distinct primes in the map. That means that by pigeonhole or whatever, if you add 1, you have to remove 1, right? I know it's a little bit hand wavy, and this idea is kind of like tricky to understand, but that's basically the idea, right? So each of these has, you know, if you kind of take the set of them, is there are 30 distinct primes, and if you add 1, you have to remove 1. So that means that the map will always have at most 30 elements, and actually it's fewer than that, like I said, because it is, you know, this thing instead of whatever. But yeah, and that's basically the idea that puts it all together, is that we're able to kind of go this, then it becomes n times 30, and then your binary, sorry, excuse me, it's going to be log n, and that's it. And that's how I did it, right? Let's go over the binary search real quick. The binary search is go from 0 to n. So we just kind of do this thing. I'm not going to go over binary search for now, because it's a Q4, it's a hard problem. You should just be strong at binary search by now. That is a prerequisite for this problem, right? And then this is the good function, and it's kind of tricky. It's kind of long only because we use map, and so there's a lot of checks. But yeah, and this code actually is fast enough in Python, but it took me so many optimizations that, you know, it's and the first time I wrote this code is mostly the same, honestly, right? It is what it is. But yeah, so you have streaks, right? It's a map. For every x, we create first we create a new streaks table. If x is equal to 1, we just kind of skip, because it ends the streak, all the streaks automatically. No point in doing a for loop or anything. Just keeps it easy, right? And then else, if x is in streaks, then that means that if x itself is in the streak, we just add 1 to it. Otherwise, we create a new entry. This is where we extend the element by 1, possibly, right? But here, it's kind of the first part, right? yeah. So then for each previous key that we see, we do a GCD. And the GCD is the part that binds everything together. The GCD lets us kind of remove these multiples from like, 2 times 3 to 3, for example, while keeping the streak alive and so forth. Yeah. And if the GCD is 1, then we just kind of skip this because, well, we don't need to kind of contain the 1 streak. Otherwise, we set the new streak of G to 1. Just as a sentinel, because we also want to extend the streak if we can from the previous of G or previous of K plus 1, right? So that means that if G existed before, then we extend it. If K existed before, we extend that to here by getting rid of, if that means that K is bigger than G, right? And so you kind of reduced, right? So this actually reduced it by 1 prime, or at least 1 prime, right? And then at the end, we also kind of, okay. So then we I guess I actually didn't need to do this yet, but yeah. But we update the streak, just to update it. And then this is the check going, okay, if any streak is bigger than target, larger than target, then we start over. So we increment 1 for using one of the max C, and then we kind of have a streak. I guess one thing that I actually should have done, now that I kind of look at it, and maybe there's so many optimizations that I could have done, because I return count is less than right? So maybe I could have done if count is greater than max C, then we just return force. So that could be an optimization as well. That's something that I actually been really bad about for some reason, like this specific optimization. It's not a huge optimization, but in a problem where everything counts, maybe it's helpful. But yeah, the idea here is that, okay, well, now this is, we put a divider here ending all streaks. So then now that's why streaks is empty, and we increment the count, and we can only use maxi, maxi number of times. So that's why you have this thing, and that's it. Overall, like I said, like I really dig this problem, to be honest. I hate that Python is kind of like butchered in this way, because what I wanted to do, and what I did the first time, is that I used collections.counter. I didn't have these if statements for x is equal to 1 or g is equal to 1. So it's more general, but apparently it's a little bit too slow. Even though in Java it's perfectly fine. So I don't know. And because of these optimizations, I actually ran into another wrong answer, because it's not precise anymore, because there's more edge cases. So yeah, but otherwise, I honestly, the problem itself, I dig this idea of both ideas really, of maybe here if we could have done it with a smaller thing, and also this idea of using GCD to kind of remove numbers and so forth. And yeah, that's all I have for this one. And of course, my computer crashed, so that was not great. But yeah, that is all I have for this one. Let me know what you think. Thanks for watching. And yeah, you can watch me solve it live during the contest now. A standard-ish problem, but I still feel like I make a lot of silly mistakes at times, so I don't know. All right, another 5 minutes. I don't know. I'm a little bit slow these days, it seems like. All right, because I knew what I wanted to do. All right, you're given an integer array nums and an integer max C. A subarray is stable if the highest common factor of all its elements is greater than or equal to 2. The highest common factor of all its element is greater than or equal to 2. Okay, what's a common? Okay, that even divides all elements. Okay, I guess that's what I would have expected. Just want to make sure. Stability is defined as the length of the longest stable subarray. Okay, you may modify at most max C element to any integer. Okay, return the any integer is interesting. That means you'll just skip that number, but well, maybe return the minimum possible stability factor of the array after at most is the length of the longest stable subarray. Minimum possible. What does that mean? Okay, let's say 510, which has 2. Change nums 1 to 7. Oh, wait. Maybe I'm misunderstanding this. Hang on. No subarray greater than length 1. has HCF upgraded into. Oh, okay. So the minimum. Huh. Not sure I understand this still, but I think I have a feel for it. Okay, so which has a stability factor of 3. So then we just have to change one of them, right? In theory. Do we have to change all of them? I don't think so. It's just subarray, right? A subarray is called stable with higher of the minimum parts of. Okay, so the longest stable subarray. I missed this part a little bit, or maybe I didn't understand it when I first read it. Longest. Okay, so that means that we just have to. Well, yeah. So we have a longest stable subarray, and then what? I mean, the tricky thing is that they're not they're not disjoint subarrays, possibly, maybe, depending on how it's set up. So I think that is maybe the immediate thing, right? Okay, you have 2, 4, and 9, 6, but there could be a case where, I don't know, maybe you have 2, 2, 2, 2, 2, 2, 2, and then maybe you have like I don't know, 10, and then maybe you I don't know. I'm trying to think whether it makes sense. Like if you have, I don't know, something that is or maybe a better one is like 6, 6, 6, 6, 6, 6, 6. And then you have 10, and then the other one, or just even just 2, and then 3, right? So we have something like this, then this is one long subarray, and this is also a long subarray. So, and they're not disjoint. I think that's a tricky problem. That is a tricky problem in general. That said, the max C thing, the change factor does make it like you can make this a prime number, and so then you could always disjoint it. Where's my water? Did I finish my water? I guess I finished my water. And here, I mean, it's just trying to figure out how to track this and dealing with off by ones possibly. Can you do it iteratively? Is the constraints? No, constraint is too big. You have 10 to the 5th. So if you just do it one at a time, trying to break it apart. And also that's not even necessarily the right way. I was thinking about like iteratively dividing them in half, but maybe that's not the, I mean, that doesn't make sense, right? Because for max C is equal to 1, then you divide 2 things in half, which is fine. But then if you have max C is equal to 2, you don't divide 1 by half and do it again. You actually take this whole thing and then you divide it by 2 thirds rather, right? You cut it twice to 3 parts. Maybe that's a more precise way. All right, give me some candy. Yeah, I think this is a binary search problem now that I think about it, right? Because we search on how many things it can do. I mean, I think this is binary search actually. I don't know why I didn't think of that earlier. Yeah, because then it almost doesn't matter. Then now the overlapping case doesn't matter because in a sense that you have to cut it off anyway from binary search. Okay, so binary search. I think binary search is right, but I think it's still a little bit tricky about overlaps. Because you can imagine, okay, let's say we want our overlap to be, let's just shrink this a little bit. This is too big, too kind of unnecessary big. So something like this, And let's say we want to test for 3, right? We test for 3 or maybe 4. Well, let's just say yeah, let's just say 4, right? If we only keep track of these 4 and then we see a 3, we ended the streak of 4. And then we may be like, oh, that's good. But no. You still have to end this streak. So you have to cut it off here instead because of this 3, right? I was about to think about it over. I think binary search is the way to go, for sure. But we have to think about how to handle this. Which I'm not quite, I don't know immediately yet. Obviously. Too much candy. We have an hour. And I don't know, I took a peek at the times, but it's just all cheaters anyway. So it doesn't really help me try to figure out how hard this problem is in terms of timing. What a useless leaderboard. How do we keep track of the sex? Okay, so maybe we can look at the primes. We only care about the primes, right? Maybe? It goes up to 10 to the 9, it's a little bit awkward though. That means that we can do surf. It's very awkward actually. I don't know why they made it that way. But okay, so let's say we do keep track of the prime, then we go we have a 3. We have a 3, and then we want to say, so we get the prime things. Okay. It means that, and maybe we have to pre-process it, which is fine. Is it still binary search, or we just need to pre-process it? No, it's binary search, because then you want to do the cut, so you don't have to think about it. Okay, fine. So for each number, factor it, and then contain the streak. I think that's fine. We just have to pre-process it, and then we look at the math and then do it, right? And because we have at most 30 numbers, or 30, yeah, 30 numbers, then it doesn't matter. Do we only have to keep track of primes? Does it matter? No, yeah, we only have to keep track of primes because even if the overlap is 4, as long as it's overlaps of 9, 1, then it doesn't matter. So okay, so we don't have to care about the number of primes, so we just have to care about primes. 10 to the 9 is wonky though. I think with using Ceph would have been pretty nice, but okay. Okay, so then how do I want to implement it? Okay, I mean, prime up to 10 to the 6. So do we still want to do Sif? I think we still want to do Sif. Is this fast enough? I don't know. I think the algorithm is relatively fast, but is it fast enough? Square root of x times 10 to the 5th is pretty not great, honestly. Can I be a little bit better? Especially since we're adding a binary search, it just seems like all the costs add up. Even though, yeah, I mean, after the pre-processing is fine, but the pre-processing is so expensive if you want to get all the factorizations of x, right? How do I binary search straight for it? What am I missing? So it could be have a big number, right? But it could have a big number. That's the problem. How many primes are there? I forget how many primes under I don't know, 100,000 there are. 78. Oh no, that's not it. How many primes are there? About 10,000 primes under 100,000. Maybe that's right, but that means that that's way too many for us to mess around with. Maybe. Why 10 to the 9? Is it that much easier? I don't know. What is the trick with the 10 to the 9? That's what I'm trying to figure out. Because if max is equal to 0, then this should be 5. If max is equal to 1, then what happens? 4 should be good. Because you remove this 3, not the other 3. Right? Because then now it becomes 4. I mean, in theory, you could... Well, in this case, the answer, you would probably even cut to 3, but... So the overlapping thing is definitely a thing, unless I'm misunderstanding the problem. How much time did I spend? I spent like 8 minutes just thinking about this already. I mean, even if max here is 0 to 0, it's just that if you don't keep track correctly, and the answer here is 5 and not 4, right? And this could be any two primes really, so any two primes. The 10 to the 9 is really throwing me off. Is it a segment tree thing? Maybe it's a segment tree thing. Can I get the, whatchamacallit, HCF? What they call it? I guess so. I was thinking about whether I can get a segment tree query of, like, just get a segment HCF. And then from that, can I? What will you do with it? Let's say you have a segment tree that gives you, I think you can, but and now, no, because you don't want the HCF of the highest common factor of the segment, because in this case, this becomes 1. This becomes 1, but that's not the thing, right? It is actually 4 that is here. So if we only have this subset, the HCF is 1, but the stability is 4 due to this chunk. So, and then maybe more when you kind of extend it. I mean, do you do a sliding window? I don't even know how. Yeah, even given a segment tree, I don't know if that helps. Because you query for a segment. And then what? And log it in square, and that may not even be fast enough if you have log square n, because then now maybe you're doing a sliding window of every chunk. Okay, so I guess you could do it that way, which is to look at every 5. In this case, if we're searching for 4, then we're looking for every 5. Then we go, okay, well, now there exists a 5, so we have to set 1 chunk. I mean, it would work, but I think it's too slow with a segment tree. What else can I do if we have a segment tree? If I could do a segment tree about a binary search, then it would be fast enough. I don't know that I can. Well, yeah. I was gonna say maybe you could build that into the segment tree, but to get the stability. But I don't. But you still have to know where to modify, which I'm not sure about. Without the binary search. We're so close. The 10 to the 9 is really throwing me off. Okay, it was 10 to the 6 as an instant sell for me, I think. Like 20 minutes ago, but or 10 to the 5th or whatever it is. Maybe 10 to 6 is fine, but also I shouldn't have done it now because I think the real contest is like starting 13 minutes, which means the load time and there might be some other issues, but yeah, well, it's fine. The overlapping thing is just weird for me. Maybe there's a principle of the overlapping thing that I'm not. I mean, the other thing is that, I mean, I did a 2 overlapping here, right? But it can't even get worse. You can imagine, you know, another way of writing this is just that you have this 2 overlap, 3 overlaps for 3 prime. But you can actually always just like add another one, right? Like, so then now that just becomes 2, 6, I don't know, 30, I guess, 30, 15, 15, 5, 5, 5, 5, 5. And then now this is also a big overlap, right? So I have to figure out how do you do this without prime factorization? That goes up to 10 to the 9. So it's not even just like you could deconstruct into 2, and you know, this can go as much as you want. And they also affect each other, right? You can't just like separate them out, I think. Because if you remove this 3 or this 5, I don't know. Like remove this 3, it doesn't help for this 5 and so forth, maybe, I don't know. They're all interlinked together. We do know how to construct a bad case, at least, maybe. I mean, even with no max C, I don't know how to figure out the answer for this, right? The longest. Maybe that's the first part. How do we figure out with no max C, no changes, how do we figure out the longest thing? I mean, DP on the primes, but actually it's not that bad. That part is easy if the numbers doesn't go 10 to the 9, but it does go to 10 to the 9, so can I bring it forward? 2 and then 6. Maybe I can just look at all the previous numbers up to, because there are only 30 primes, right? So then maybe that means that we only have to look at 30 previous numbers. Maybe. Maybe that. I don't know if that makes sense, but let's see. Yeah, there can only be 30 primes, so maybe that is reasonable. So we don't have to generate the primes. We just have to generate what it is previously next to, right? Maybe that's right. Maybe that's the DP. Okay, what would that look like, Larry? All right, let's just write it without max C for a second. So then now we have for X nums, right? Maybe C, something like that, right? Or streaks maybe. And then we have streaks of X is equal to 1, say. And then now we look at for K in streaks dot keys, something like that. Then now we go GCD, right? This HCF thing is weird because I just call it GCD. Are they trying to fool you or something? I don't know. Okay. And now streaks of G is equal to something like this, plus 1, or streaks of K plus 1, right? Something like that. And then something like this, but it's not quite right because we don't want to, it should be new streaks. I think that's the thing. Okay, so then this is the new streaks. So let's just say we have the previous streaks and the new streaks. I think that's where we have to, because you have to be able to remove streaks that ended, right? So okay, yeah, okay, that's fine. So we have a new streak, and then for new streaks is equal to the previous streaks at G or K plus 1. Is that right? No, it's not quite right. In the sense that no, it's fine because it'll get extended in another one. Because my thing is that if that's like 10 and 20, then 10 is the GCD, but maybe you want to keep the streak on 2, but it only comes into play if there's a 2 in the future anyway. Maybe something like this. Maybe that's right. And then streaks as you go to end streaks. And then maybe we just print it out every time for me to take a look to see if this is roughly right. Okay, so you have 3, and then 1 is, well, we have to remove 1. I think that's, well, I mean, maybe we don't, I don't know, it doesn't matter. 5 is 1, 10 is 2. Okay, that looks kind of what we want. I mean, we could remove 1 anyway, it's not a big deal. It's just that we don't care about it. So 2, at the 6 is going to be 2, 3, 8, 1. Why does 8 not intersect with 2? That's the thing that I want. Or 6. Streaks. 8 and 6. What is 8 and 6? Technically, I guess maybe this is max of 1 or streaks of X plus 1, which is fine. But why is this 8 and 6 is what? 3 and 4, so just 2. So okay, I guess that's just a streak of 2 at 2. I guess that's why. Okay. 2, 4, 6, 9. Okay, and then maybe we'll try the test case that I was trying to this thing. 2, 6, 3, 15, 15. Let's just say 2. Whatever. I'm just trying to see how much work this has done. And then 2, so then the longest would be at 4. 3 would keep going at 4, 5, which is what we expect. And then 6 is, or 5 is going to go all the way to 9. The 1 we don't care about. We can throw away 1. Okay. Huh. Maybe this is the way that I think about it then, right? Because then now, binary search should be straightforward-ish, right? Maybe we have a... just go good, Larry. You could always go good. Okay, what does that look like? So given a target, we have count is equal to 0. So then, okay, you have this thing, right? Okay, so now that means that should we add a thing here, right? So for k in streaks.keys, if streaks of k is greater than target, then we just increment by 1, and then streaks is equal to collections.counter. Right, but we want to delete streaks of 1 if it exists. Just so that, because I think this gets triggered otherwise. And we just return count is less than equal to max C, right? And then now we can do a binary search. That was 0. Does that ever make sense? No, I don't think it could ever be 0. And then what am I doing again? Oh, the longest thing. So that's just n, right? And n plus 1. I always forget it was. No, it's inclusive, Larry. Come on, you're smarter than that. You've done this a billion times. Okay, so if this is good, then we want to try a smaller number. So right is equal to mid, else left is equal to plus 1, and we just return left. So we should see 1, 1, 2, or hopefully it just terminates. Why does it not terminate? Right is equal to mid. Am I really bad today? Maybe I am really bad today. I feel like I never really struggled with this before. I don't think this will time out, especially for these inputs anyway. So that means my binary search is wrong. Oh, why did I not do it by 2? Wow, Larry. Okay. Alright, 1, 1, 1, 2 is right, and 3 is from this thing, which I don't know if it's right. But alright, YOLO submit. No. I mean yes, but also maybe not yet. In that nums is equal to say 2 times. I don't know that this is the worst case though, because I mean this is definitely a bad case. Is it the worst case? Oh, it's because it depends on max C. It doesn't tell me the time though, does it? How do I get it to tell me the... yeah, sorry friends, my computer crashed in the middle of that. So annoying, right? Okay, very relatable. That kind of added, I don't know, at least 5 to 8 minutes to my time. I don't know exactly. I think this is the first time it actually happened, but we were about to submit too. Okay. I mean, I think I was not super happy with the time, but I think this is YOLO time, so let's just YOLO submit. Just was, it's very annoying. I mean, it may still time out, honestly, but I'm really kind of a little bit confused and lost just because of my computer crashing. Hopefully this is fast enough. Oh, well, wrong answer is not what I expect. Oh, 0. Oh. Okay. I mean, I guess I didn't expect 0 to be a possible input. That's why I put this at left. But let's go YOLO submit that. But oh, with no stable. Oh, I see. Huh. Okay. Maybe I just didn't. Yeah. We'll see if this is wrong. Oh, right or whatever. Ooh, time limit exceeded. Okay. Oh, 995 over 998. So we're very close, but and even this is like fast enough. So I feel like this is a case of of maybe if I convert it to another language that'll be fine. But Leetcode's a little like maybe I could be a little bit smarter about this, but it is what it is. So for example, if G is you go to 1, we continue. Maybe that's a little bit faster. I don't know. But now we're in like optimizing time situation 2.4 seconds, which is kind of like yucky, right? Okay, maybe this is much better. Oh, I should have converted these max. I didn't think I was kind of rushing this, so I didn't feel like I needed to. But again, this is like Leetcode being silly more than I need to, right? Oh, and then now we mess up because of 1. If g is equal to 1, we continue. Why is this 0? A subarray link point is stable if its element. Okay, so I guess there's this like weirdness thing. It does save me time, but I feel like this is also honestly. All right, let's just run this again with this, and then we'll see if that makes it a little bit faster in general. So okay, so the F max doesn't change it, but that too much for now. Though, there's so many issues due to things crashing and everything. I mean, it's the 0 case that is a little bit awkward, so maybe we should just do a 1 thing. How do we handle 1, right? Maybe something like if x is equal to 1, and we just continue, maybe? I don't know. Because then now we just have a new thing, right? Does that give me 0? No, well, I have to. No, I still output 1. Oh no, I didn't use this case. Did I use this case? Maybe I did. It's this one. Output 0, so that's right. It is kind of crappy that you don't get the thing about it anyway. I don't know if this is the right answer, but alright, let's YOLO submit. Maybe I'm just confused right now, but in general, to be frank, I don't know if this is the right way to handle that case. 996 out of 998. So I mean, again, this is like a way Leetcode E, like how can I tell whether I'm timeouting or not kind of thing, right? And it's just Leetcode being bad. So let's just convert to Java. I don't know why this is taking so long, but yeah, maybe that's fine. Alright, let's see if it is better in Java because Leetcode sucks. I blame it on Leetcode. Like maybe it is Java 18 only? Is there no way to do Java math GCD? Is that not a thing? I always forget, it's been a while. Alright, so there isn't. Okay, fine. Where is it? 937. Okay. What's the answer? 112. That looks right, except for 8. I think. Oh no, that's the timeout one. YOLO submit. I should have checked the time, but that's fine. Maybe it's still a little bit slow. I mean, so I got it like pretty early, but Leetcode it being Leetcode, it is what it is. Well, and the computer crashing. That obviously was not great. I had to check on my computer after recording, but yeah, where's my time? We have 27 minutes left. But I crashed for like 10 minutes or so, so I don't know, maybe something like that. And all four wrong answers is due to the optimization I had to make. because Python isn't fast enough. Can I do it faster in Python? I guess maybe that'll be my upsell for now. Like maybe we don't use counter, maybe we use okay, so just I lost my test cases already. All right, I mean this is upsolving anyway, but if x is in streaks, I mean it's always going to be this. Okay, so then maybe we just write it out. So if something like that. Maybe I could even just write it in line, but maybe that's in it. I think honestly maybe this could have been a little bit cleaner. I don't know that this is quite whatever about it. Does this even work? This looks like it works. YOLO submit. Again, maybe too slow, but that's fine. I mean, we already finished, right? So, but it is. So I guess using that instead of counter would have saved me enough time to get it time in. But I mean, I was just mostly lazy. But actually, maybe not even needed. Yeah. Because I think even if this is, maybe I'm wrong. Let's see. Because I think. I see. I think there is something that I was doing a little bit awkward, which is that I was creating keys as I was doing it. So if I didn't have this, so maybe I could, maybe if I still had this, it had fewer things. But still, it's just such a minor thing to have to, you know. Let's see. Because I think this actually maybe creates additional keys that we throw away. So maybe that does it too many times and not just the map and counter overhead. Counter does have overhead for sure though, but it is definitely, yeah, okay. So maybe maybe it is a counter. It is what it is. All right, I mean, yeah, that is all I have for this one though. Let me know. Thanks for watching, everybody. Hit the like button, hit the subscribe button, join me in Discord. Let me know what you think about this contest, these problems, and everything in between. Stay good, stay healthy, to good mental health. I'll see y'all later and take care. Bye-bye.